Imagine this. You're walking along a sandy beach, the salty air filling your lungs, waves crashing in the distance. Suddenly, your metal detector beeps sharply. Your heart races as you dig into the sand. Is it just a bottle cap, a lost coin? Or maybe something much older, hidden beneath the surface for years? The thrill of discovery rushes through you. But have you ever wondered, how does this amazing device actually work? At its core, a metal detector is a fascinating piece of technology that takes advantage of physics and electromagnetic waves. It all starts with the transmitter coil, a loop of wire inside the search head. When you turn the device on, an electrical current flows through the coil, creating an invisible magnetic field that pulses in and out, extending into the ground below. Now, here's where the real magic happens. When this magnetic field encounters a piece of metal, something fascinating occurs. The metal reacts by producing tiny electric currents, known as eddy currents. These currents generate their own magnetic field, separate from the detector's original one. The receiver coil inside the search head picks up on this new field and sends a signal to the control box. The control box processes this information and triggers the familiar beep that tells you metal is nearby. Different metals react in different ways, and advanced metal detectors can actually distinguish between them. This is why some detectors can tell the difference between an aluminum can and a gold ring. They analyze the signal's strength, frequency, and pattern, giving you clues about what might be buried below. But not everything is detected the same way. The depth at which a metal detector can locate objects depends on a few factors, like the size and type of metal, the settings on the detector, and even the ground itself. Larger objects and highly conductive metals, such as silver and copper, can be detected deeper underground, while smaller or less conductive metals like aluminum or stainless steel might only be found near the surface. The type of soil also matters. Wet sand, mineral-rich dirt, or rocky ground can sometimes interfere with the signals, making it harder to pinpoint objects. Some metal detectors use an advanced technique called pulse induction, which is especially useful in difficult environments like beaches or gold-rich areas. Instead of relying on continuous electromagnetic waves, pulse induction sends short bursts of energy into the ground. When these bursts hit metal, they create a unique signal that the detector recognizes, allowing it to ignore interference from minerals in the soil. That's why pulse induction metal detectors are often used by serious treasure hunters searching for gold nuggets or relics buried deep underground. Speaking of treasure hunting, there are a lot of myths about metal detectors. Many people think they can find anything underground, but that's not true. Non-metallic objects, deeply buried items, or objects in highly mineralized soil can be tricky to detect. And while gold is one of the most sought-after metals, it's actually harder to detect than silver or copper because it's not as conductive. While most people associate metal detectors with hobbyists searching for coins and lost jewelry, they have a much bigger role in the world. Archaeologists use them to locate ancient artifacts. Construction workers rely on them to find hidden pipes and wires. Security personnel use them in airports and public places to detect concealed weapons. Scientists even use them to locate meteorites, pieces of space rock that have fallen to Earth. So the next time you see someone sweeping a beach with a metal detector, remember, they're not just listening for beeps, they're searching for history, waiting to be uncovered. And if you've ever thought about trying it yourself, why not give it a shot? Whether you're looking for treasure, lost relics, or just enjoying the thrill of discovery, you never know what you might find beneath your feet.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.